Hello everyone. So in the last two videos we covered all the theorems except Pythagoras part, but we covered all the theorems of maths chapter triangles, including the tests of similarity. So today we are going to start with NCERT exercises. I'm going to solve some selected questions which I feel are interesting, are different, are little difficult, little tricky. I'm going to target those questions. I'm going to solve it for you. I will try to show you how to solve these kind of questions so that when I give you homework, you are able to solve the rest of the questions yourself. Uh, there are five exercises which I'm trying to cover today, from 6.1 to 6.5, I think, or 6.4. I'm not sure about that. But yeah, so up to Pythagoras theorem, whichever exercises are there, I'm going to solve selected questions out of all of them. And you will see how to solve them. Okay, so let's start. Exercise 6.1 is simple. It is based on the introductory information which I gave you in the first video. Okay, so these are all the fill in the blanks. We can do it quickly. I'm just going to highlight the correct option. Okay, all circles are congruent or similar. They are all similar. All circles are similar. Because of their different radii, they cannot be congruent. Two circles are congruent only if they have the same radii. But if they have different radii, they will be similar circles. Or all squares are similar again because of their length of their sides. If the length of the sides are different, then the squares will be similar, not congruent. All dash triangles are similar. All equilateral triangles are similar. All isosceles triangles are not similar because in equilateral triangles, all the angles are always 60-degree. So any two equilateral triangle, no matter if their sides are of different length, their angles will still be 60-degree each. That means they will be equiangular, and we know that equiangular triangles are always similar. Two polygons of the same number of sides are similar if number one, their corresponding angles are dash and their corresponding sides are dash. Okay, so two polygons. See, the smallest polygon which we know, a closed figure having the minimum number of sides, is a triangle. Okay, so in triangles we know that two triangles are similar if their corresponding angles are equal and their corresponding sides are proportional. Okay, so we know that fact. We have discussed it in great detail while we were doing theorems. So that is the benefit. Um, these are the answers. So we have discussed the theorems in so much of detail that many of the questions will be repeated and we can skip them quickly and move to some different types of questions where we can see applications of the theorems which we have already learned. Okay, give two different examples of a pair of similar figures and non-similar figures. Two different examples. Okay, similar figures. Two circles can be similar, two squares can be similar, two equilateral triangles can be similar. Okay, two non-similar figures. Non-similar figure, let's say a scalene triangle and an equilateral triangle, a scalene triangle and an isosceles triangle. These are non-similar figures. State whether the following quadrilaterals are similar or not. No, they are not similar. See, their sides are proportional. The side of rhombus over here is 1.5 centimeter. The sides of square are 3 centimeter. So there is a ratio of 1:2 between the sides of rhombus and the square, but the angles are not equal. Two similar figures must have equal corresponding angles, and the ratio of their corresponding sides must be equal. Here the angles are not equal. This angle is not 90-degree. Here the angles are 90-degree, so they are not similar. Okay, next exercise, quickly moving to 6.2. Now 6.2 exercise is based on basic proportionality theorem, its converse, and its applications. The results based on basic proportionality theorem, its applications. Okay, So in the figure 1 and 2, DE is parallel to BC. DE is parallel to BC. Find EC in 1 and AD in 2. Find EC in number 1, figure number 1, and AD in figure number 2. So in figure number 1, I will take EC as X. In figure number 2, I will take AD as Y. There is no any specific reason why I have taken them as X and Y, just not to get confused. If we take both as X, then you will get confused. Okay, so in the first figure, we know that DE is parallel to BC. If DE is parallel to BC, we can apply basic proportionality theorem. So we can say that AD upon DB is equal to AE upon EC. Why? Because of basic proportionality theorem. So 1.5 upon 3 is equal to 1 upon X. Okay, so this will get cut and 2 will come over this side. So this will be X is equal to 2. So the value of EC or X is nothing but 2. Over here we know that DE is parallel to BC. So again, by applying basic proportionality theorem, AD upon DB equals AE upon EC. Very simple question. These kind of questions can be asked to you for 1 mark in your exam. So Y upon 7.2 is equal to 1.8 upon 5.4. So Y is equal to 5, sorry, so Y is equal to 1.8 multiplied by 7.2 upon 5.4. Okay, so Y, sorry, 1.8, 3s are 5.4 and 2.4s are 7.2. So Y is equal to 2.4 centimeters. So this Y is 2.4, AD is 2.4. So let's check our answer. The first answer is 2 centimeter and the second answer is 2.4. 2 centimeter and 2.4 centimeter. Absolutely correct. Okay, so this is the way you should write it with proper statements and steps. Okay, so these kind of questions can also be asked to you in MCQ type because that's the mode of examination as of now. So beware that these kind of questions can be asked. Okay, E and F are the points on the sides PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR or not. Okay, so here we have to apply converse of BPT. Okay, we know that this is the figure. They have given us some measurements, and we have to, through the measurements, we have to understand whether EF is parallel to QR or not. In the first case, PE is 3.9 centimeter. PE is 3.9 centimeter. So I'm going to write every case on the same figure and try to find out whether the triangles are whether line EF is parallel or not to Q1. Okay, PE is 3.9, EQ is 3, PF is 3.6, EQ is 3 centimeter, PF is 3.6 centimeter, and FR is 2.4 centimeter. Okay, so let's find out whether EF is parallel to QR or not. See, EF will be parallel to QR if and only if PE upon EQ's ratio is equal to PF upon FR's ratio. Okay, what is PE upon EQ? 3.9 upon 3. See, 3.9 upon 3 is 1.3 upon 1 or 13 upon 10. Let's find the ratio of PF upon FR, that is 3.6 upon 2.4. So 12 2s are 12 3s are. So we are getting 3 by 2. So PE upon EQ is 13 by 10 and PF upon FR is 3 by 2. So PE upon EQ is not equal to PF upon FR. So that's why we can say that, therefore, Therefore, EF is not parallel to, I'm sorry, I wrote not equal to, no, it should be like this, is not parallel to, EF is not parallel to QR. So like this you can check, okay, whether a line is parallel to any other line or not. Now what I want from you guys, pause the video and try question number 2 and 3 yourself. They might be little tricky, little difficult, but I want you to try. Remember that if you cannot prove PE upon EQ is equal to PF upon FR, if you can prove PQ upon EQ is equal to PR upon PF, or let's see if you can prove PE upon PQ is equal to PF upon PR, or if you can prove EQ upon PQ is equal to FR upon PR. You know, do you remember this? These are all the results of basic proportionality theorem. So even if you can prove any of the result of basic proportionality theorem, let me write all these results for you in the given triangle. See, EF will be parallel to QR if and only if and only if, number one, uh, PE upon EQ should be equal to PF upon FR, or number two, PE upon PQ should be equal to PF upon PR, or number three, EQ upon PQ should be equal to FR upon PR. Can there be fourth case? I wrote PQ upon PE, EQ upon PQ, I wrote PE upon EQ. Yeah, I think if one of these three cases are proved, can be proved, then we can say that EF is parallel to QR. Then we can say that EF is parallel to QR. So I want you to pause the video and try question number 2 and 3. Draw the diagram, try question number 2 and 3, and find out whether one of these three cases are true or not. If they are not true, then the lines are not parallel. But if one of these three cases are true, then the lines EF and QR are parallel. So please try it. Okay, I think if you have done it, let's check what is the answer. The first one we found out was not parallel. Yes. The second one is parallel, and the third one is also parallel. So I hope that this is your calculation which you are getting for the second and third one. See, for the second one, the ratio which they are getting is PE upon EQ is equal to PF upon FR directly. PE upon EQ is equal to PF upon FR. That is the direct ratio, the first ratio which we used in the first question also. But for the third one, the ratio that they have got, actually for the third one, they have got PQ, PR, and hey, they have got PE and PE. That's not possible. Let me check what is the actual. Okay, PF is 0.36. Okay, so if you have a problem here, this is PF. If you did not get due to this is PF, and now you should try again, you will get it. So we have PE and PF, PE and PF, and we have got PQ and PR, PQ and PR. So the second one, the second relationship will help you to prove that the third case is the case of parallel lines. EF is parallel to QR. Okay, so slight change. but we have made the clarification, and this question was an easy one. Let's go ahead. Let's go to the next question. Okay, so in the figure, let me make it a little smaller so I can write and show it. In this figure, LM is parallel to CB. Let me show it in the figure. LM is parallel to CB and LN is parallel to CD. LN is parallel to CD. I hope you can see that. Prove that AM upon AB is equal to AN upon AD. AN upon AD. That's very simple to prove. Okay. So in some people might have this idea that should we write given to prove construction? Yes, of course. This is a geometry, this is a proof geometry chapter where you need to write all these things. They carry marks. Okay, so given to proof construction, everything with the diagram carry 1 mark. So if you don't do all that, your 1 mark will be cut. So I recommend that you write all these things. Figure is already drawn, so I'm just going to start with given LM is parallel to CB, LN is parallel to CD. To prove AM upon AB is equal to AN upon AD. All right, and construction, no, not required. Proof, yes. In triangle, in triangle ABC, in triangle ABC, if you see triangle ABC, ML will be parallel to BC, right? Or LM is parallel to CB, whichever way you want to say. This is given. Therefore, we can say that AM upon MB, AM upon MB is equal to AL upon LC, number 1, correct? In similarly in triangle ADC, do you see triangle ADC? In triangle ADC, NL or LN parallel to DC or CD, whichever way, both are correct. Okay, I did not write the reason. This is because of BPT. Okay, now if your teacher tells you have to write the full thing, again I'm telling you, please do that. You have to write basic proportionality theorem. If it is the case according to the teacher, please do that. Follow the instructions for this trivial matter from your school. Please do not argue over there. Okay. NL parallel to DC, so we are getting AN upon ND, AN upon ND is equal to AL upon LC. This is equation 2, and this is by basic proportionality theorem. Okay, now if you compare equation 1 and 2, both the ratios in equation 1 and 2 are equal to AL upon LC, so we can equate them directly. Therefore, from 1 and 2, AM upon MB is equal to AN upon ND. What we have to prove? AM upon AB is equal to AN upon AD. That we don't have it yet, but we can do that. First, we'll take a reciprocal. So I'm going to take some space. Yeah. So taking reciprocals on both sides, we have MB upon AM is equal to ND upon AN. MB upon AM is equal to ND upon AN. Now, adding 1 to both sides, we have MB upon AM plus 1 is equal to ND upon AN plus 1. So we have MB plus AM upon AM is equal to ND plus AN upon AN. What is MB plus AM? Okay, in the figure we'll find its answer. MB plus AM is AB. So we have got AB upon AM, which is equal to, what is ND plus AN? In the figure, ND plus AN is AD. So here it's AD upon AN. So see what we have to prove. Again, I'm telling you, look at the thing which has to be proved. AM upon AB, we have to prove AM upon AB is equal to AN upon AD. Okay, we have got exactly reciprocal of what we have to prove. So again, taking reciprocal on both sides, we get AM upon AB is equal to AN upon AD. AM upon AB is equal to AN upon AD. Correct? So we have proved it. This is the method. This is the way you should write a proof. This is a typical, you can say, proof based on basic proportionality theorem. So I hope you have noted it down by pausing the video in between. If you don't note it down, then what will happen? You will never know that how to write, what are the steps in writing the proof based on BPT or similarity or whatever. So whichever questions I'm doing over here, or whichever I'm leaving for you, you have to note down all the questions. Okay, so all the NCERT exercises will be noted down with you while watching the video, and I'm going to give you another homework. Okay, no homework from NCERT will be given to you. Extra homework will be given to you, which is non-NCERT for practice. Some challenging questions so that you should be comfortable with the topic. Okay. Very nice question we have. So this question is about visualization. What is given? Given is DE is parallel to AC. DE is parallel to AC. Do we see DE and AC? Yes. And DF is parallel to A. DF is parallel to AE. DF is parallel to AE. Do you see that? Now there is just one triangle ABC, but in one triangle ABC we have two pairs of parallel sides, DE and AC and DF and AE, and that makes this question very interesting. Okay, so what is to be proved? To prove, we have to prove BF upon FE. BF upon FE is equal to BE upon EC. BF upon FE is equal to BE upon EC. See, BF upon FE is over here, BE upon EC is over here. So you might be thinking that how to prove this. But this is really interesting. If you pay attention, I'm just going to show you how to prove it. Proof. After I prove it, you will pause the video and without copying down, you will solve it yourself. And if you have any problem, you can look at my solution. But don't copy. And you must note it down. If you are not noting it down, see, I will ask you to send me the solved example as homework. Those who don't send me, I will understand that they have not noted it down. They will not be entertained when exams come closer, or when whatever issues arise regarding their performance. If their parents tell me that why my child is not performing, I'm going to be very open to them about what my instructions were and what are followed by the child. So the picture will be very clear. So follow my instructions. Otherwise, it will be a difficult time for you. Remember, answerability is not lying only with me. I am doing my duty. It also lies at your end. Okay, let's start. First, in triangle ABE, remember, you have to focus on one triangle first, that is ABE. I'm marking that triangle with green ink. So focus on the triangle with green ink only. Can you see triangle ABE? In triangle ABE, DF is parallel to AE, right? Therefore, you can say that BD upon DA, BD upon DA is equal to BF upon FE. Why? Basic proportionality theorem. Correct? BD upon DA is equal to BF upon FE. Can you visualize? Can you find it what I'm suggesting in the figure? If you can find it in the figure, then it is very easy for you. If not, then you need to open your eyes and visualize. I need to improve your visualization skill. Otherwise, it will be difficult. If you cannot visualize, it will be difficult. Okay? Sure. Next triangle which I want you to visualize in this complicated figure is triangle ABC, the big triangle. I'm going to mark the big triangle with red ink. Now visualize the triangle with red ink, and I'm also going to mark the parallel lines with two red inks. So two green inks and two red inks which you see are the parallel lines. Okay, so in triangle ABC, DE is parallel to AC, therefore BD upon DA is equal to BE upon EC. Can you see that? BD upon DA is equal to BE upon EC. Why? Basic proportionality theorem. Okay, so this is equation 1, this is equation 2, and we can say that from 1 and 2, from 1 and 2, see both the ratios begin with BD upon DA. So we can directly say that BF upon FE is equal to BE upon EC. BF upon FE is equal to BE upon EC. That's what you needed to prove, right? So hence proved. Okay, you understood this? Very easy. Yeah, the only thing you have to learn is visualization. Then slowly these problems will be very simple for you. Let's go to the next question. Okay, here in this question I'm going to give you hint, but I expect that you will solve it yourself. So in the figure, I'm going to highlight and everything for you, but you are going to solve it. Okay, so in the figure, DE is parallel to OQ, DE is parallel to OQ, and DF is parallel to OR. DF is parallel to OR. Show that EF is parallel to QR. EF is parallel to QR. So let me give you the hint. Given to prove proof, there is no need of construction. Diagram is already there. You need to first note these things down. After noting them down, follow my instruction. My instructions are that first you consider this green triangle. Okay, in this green triangle, which two lines are parallel? Which two lines are parallel in this green triangle? These two parallel lines are also drawn in green. Can you tell me? ED parallel to QO, right? So can you apply BPT? What you will get? PE upon EQ is equal to PD upon DO. Okay, make it equation number 1. Now consider one more triangle, which I am going to mark in red. Okay. Which two lines are parallel in this red triangle? DF is parallel to OR. DF, DF is parallel to OR. DF is parallel to OR. So, can we apply BPT here? Yes. PD upon DO is equal to PF upon FR. Give it equation number 2. Now, in both the equations, you will find equation 1 and 2 that PE upon EQ is equal to PD upon DO and PD upon DO is equal to PF upon FR. So, from 1 and 2, you can say that PE upon EQ is equal to PF upon FR. So, by converse of basic proportionality theorem, EF is parallel to QR. Now, you can from PE upon EQ is equal to PF upon FR, you can consider the whole triangle PQR and you can say that EF is parallel to QR. So that is proved. If you have understood this, please pause the video right now and solve the whole thing. Then I can show you what is the solution. Okay, please pause the video and solve the whole thing as per my instructions. I have already given you lots of hints. This is very easy question. Okay, I hope that you have solved it. Let's look at the solution. This is how you need to write. So they have not written given to prove, but I recommend that you please write it in the pattern which I have written previous questions, previous solutions. Okay, let them write this way, but we have a proper method with which we will write the solution. Anyways, so this is the step which they are showing, and exactly PD by DO they are equating in both the equations 1 and 2, and then through this, by converse of basic proportionality theorem, EF becomes parallel to QR as my instructions given earlier. Let's go to the next question. So these all are simple questions. They are not difficult questions. So that's why you can try them on your own. Let's see what they have given in this question. So A, B, and C are the points on OP, OQ, and OR respectively, such that AB is parallel to PQ, AB is parallel to PQ, AC is parallel to PR, AC is parallel to PR, and BC is parallel to QR. No, show that BC is parallel to QR. Okay, we have to show that BC is parallel to QR. That means we have to show that OB upon BQ is equal to OC upon CR, which can be easily shown. Okay, so first you write given to prove. No construction is required. Diagram is already given. Proof. In the proof, listen to my instruction. This is also to be done by you. First, you consider this triangle, the green triangle. In the green triangle, POQ, AB is parallel to PQ. So by BPT, PA upon AO is equal to OB upon OQ. No need to repeat myself. I have said it very clearly. If you want, hear it again in the video. If not, you understand what I said. In triangle POQ, AB is parallel to PQ given, therefore by BPT, OA upon AP is equal to OB upon BQ. Yeah, that is the correct way. We always start the ratio from the vertex. Okay, this is number 1, equation number 1, which I just told you. Now, consider another triangle in which you have to apply BPT. That is triangle POR. So, in triangle POR, AC is parallel to PR. So, we can say that OA upon AP is equal to OC upon CR. Number 2 by BPT. So, we have got two equations in which common is OA upon AP. And OA upon AP is equal to OB upon BQ and OC upon CR. So, OB upon BQ is equal to OC upon CR from 1 and 2, and therefore BC is parallel to QR by converse of BPT. Very easy. Please pause the video and note it down. I will show you the solution. Okay, I hope that you guys are done. Let's see the solution. As I told you, they have considered both these triangles, which I already told you, and found the ratio OA upon AP equal to these two ratios, which are equated ahead, and by converse of BPT we have proved BC parallel to QR. Okay, so I hope that you have written it properly. Let's go ahead. Okay, this question: prove that line drawn through midpoint of one side of a triangle parallel to the other side bisects the third side. This is converse of midpoint theorem, which we proved in the first video of theorems, if you remember. So how to prove converse of midpoint theorem using using BPT? That's what we have done. So you no need to do this again. We have already done this question while we were doing theorems, and I hope that you have written all the theorems. If you don't remember this theorem, I suggest you look at that video again where I have proved this for you. And I've told you 100 times this is from class 9th. This is converse of midpoint theorem, and we will prove converse of midpoint theorem using BPT, which was like just 4 steps. So that is already done. So we will go ahead and look at the proof. So the proof is this, very simple. If AD upon DB is equal to AE upon EC, then DE automatically becomes if DE is parallel to BC, then AD upon DB becomes AE upon EC, and if AD is equal to DB, AE also becomes equal to EC, and E is midpoint of AC. Okay, so this is converse of midpoint theorem. See, that's why we did all the theorems in the first video, because most of those theorems which are applications of BPT are included in the exercise of NCERT. So we have done it earlier because we don't have to do it again and again, and that makes our basic concepts also very strong. Okay, so we'll go ahead. Again, one more theorem which we have done in class 9th, the midpoint theorem. Line joining the midpoints of any two sides of triangle is parallel to third side. So this is midpoint theorem, which we have to prove using converse of BPT. Okay, so this is the method with which we have proved it earlier already in the first video. Again, I'm repeating, so I'm not going to do this. Skip it and go ahead. This one is also done by us. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other. Show that the ratio of the diagonals are proportional. We have already done it. They have joined E and F. We have just joined O to E over here, if you remember. And by BPT we proved the ratio of the two diagonals are equal. Okay. Converse of that theorem, that if the diagonals intersect each other in equal ratio, then it is a trapezium. This is also done by us while we were doing the proofs. So this is done. We are just moving past. So these are all applications of BPT. Okay, so we are on the third part, that is similarity. Now I'm going to stop this video over here. I'm going to make a new video. So I have covered two exercises of NCERT, one based on introduction to similarity and the second based on BPT and its applications. The third exercise, which is on similarity, will be done in the next video, where I'm going to cover the whole topic of similarity. Then we'll move to the next topic, that is ratios of areas of two similar triangles, and that's it. I think up to 6.4 we have to do. So next video will hopefully cover 6.3 and 6.4, because I don't know how many questions from these two will have to be done. Okay, so that I'm going to cover in the next video, and then I'm going to focus only on Pythagoras theorem. That will take 2 more videos. So I feel that, can you imagine how big is this chapter? If we want to cover everything 100%, this chapter is huge. Okay, it has the small details which we have to focus on and revise again and again. Only then the chapter will get covered completely. Otherwise we'll miss out some parts here and there. Okay, so I'm going to start with similarity in the next class. Till then, bye bye.